Now we are moving towards section 8, that is repair, alteration and re-rating of the piping system. In section 7, we have seen that how to do data analysis of any data that you get during the inspection of a piping system. Now let's see how to do repair and alterations. So section 8, repair and alterations, general. The principles of ASME section 8 or the code to which the piping system was originally built shall be followed to the extent practical for in-service repairs. When ASME B313 cannot be followed because of its construction coverage, such as revised or a new material specification, inspection requirements, certain heat treatments, and pressure tests, the piping engineer or inspector shall guide by API 570 in the lieu of strictly conforming to B313. So, whenever possible, we'll generally try to use the original construction code, but where not possible, we need to understand the requirements of API 570, and that shall be taking the precedence. We should strictly follow the requirements of API 570. Authorization: all repair and alteration work shall be done by the repair organization as defined in section 3 and shall be authorized by the inspector prior to its commencement. The authorization for alteration work to a piping system may not be given without the prior consultation and the approval by the piping engineer. The inspector will designate any inspection hold points required during the repair and alteration sequence. The inspector may give prior general authorizations for limited or routine repairs and procedures, provided that the inspector is satisfied with the competency of the repair organization. This means the authorization will be given by the owner with the will be given by the inspector with the consultation of the piping engineer. Okay, and if the piping engineer is consulted, the inspector will designate hold points also. So hold points are points beyond which no work can stipulate until the hold point has been witnessed or examined. Okay. Next is approval. Obviously, whenever the term approval is there, always understand that approval is always going to be given by the owner or user because it is essentially the component of the owner and user. He has to give the approval. All proposed methods for design, execution, material, welding procedure, examination, and testing shall be approved by the inspector or the piping engineer as appropriate, but the hold points are going to be laid down by the inspector. The owner user approval on steam welding is required. Welding repairs of cracks that occur in service should not be attempted without prior consultation with the piping engineer in order to identify the correct cause of cracking. Examples are cracks suspected of being caused by vibration, thermal cycling, thermal expansion problems, and environmental cracking. The inspector shall approve all repair and alteration work at the designated hold points, and after the repairs and alteration has been satisfactorily completed in accordance with the requirements of 570. Welding repairs. So you can have temporary repairs. For temporary repairs, including on steam, a full encircled welded split sieve or box type enclosure design by the piping engineer may be applied over the damaged or corroded areas. See various articles of ASME PCC2. PCC2 is basically repair of piping systems. Longitudinal cracks shall not be repaired in this manner unless the piping engineer has determined that the cracks would not be expected to propagate from under the sleeve. In some cases, the piping engineer need to consult the fracture analyst. The design of the temporary enclosures and repair shall be approved by the piping engineer. If the repair area is localized and specified mean yield strength of the piping is not more than 40,000 psi and a fitness for service analysis shows it is acceptable, the temporary repair may be made by the fillet welding and a properly designed split coupling or plate patch over the pitted or locally thinned area. So you can have a patch on that area and that patch can be treated as a temporary repair. The material for the repair shall match the material of the base. So whatever the material of the piping system it is, the same material patch you will need to install unless approved by the piping engineer. So unless a piping engineer tells you something else, you need to do something else, but generally it is the same material. A fillet welded patch shall not be installed at the top of existing fillet weld patch. When installing a fillet weld patch adjacent to the existing fillet weld patch, the minimum distance between the toe of the fillet weld shall not be less than 4 under root RT. This is a very important question. So you need to understand that two fillet weld patches will have at least 4 this distance between them. Okay, where D is the distance, R is the inside radius in inches, and T is the minimum required thickness of the fillet weld patch in inches. For minor leaks and thinning below T minimum, properly designed enclosure may be welded over the leak or a thin piping where piping system is in service, provided the inspector is satisfied with the adequate thickness remains in the actual location of the proposed weld and the heat affected zone, and the piping component can withstand welding without the likelihood of further material damage, such as from caustic service. Any leak in class 1 service or where a risk ranking is determined to be high shall be first reviewed by the piping engineer to determine if the work can be safely performed while the system remains on stream. Temporary repair should be removed and replaced with a suitable permanent repair at the next available maintenance opportunity. Temporary repairs may remain in the place for longer period of time only if approved and documented by the piping engineer. Permanent repairs: the repairs to the defects found in the piping component may be made by preparing the weld groove that completely removes the defect and then filling the groove with the weld deposited metal in accordance with 8.2. Corroded area may be restored with the weld metal deposited in accordance with 8.2. Surface irregularities and contamination shall be removed before the welding. Appropriate non-destructive examination methods shall be applied after the completion of the weld. If it is feasible to take the piping system out of service, the defective area may be removed by cutting out the cylindrical section and replacing it with the piping component that meets the applicable code. The insert patches may be used to repair damaged or corroded areas if the following requirements are met. Full penetration groove welds are provided for class 1 and class 2 piping system. The weld shall be 100% radiograph or ultrasonically tested using non-destructive examination procedures approved by the inspector. The patches may be any shape but shall have rounded corners of at least 1 inch minimum radius. Again, see ASME PCC 2 part 2 for more information on this. Non-welding repairs on stream: the temporary repairs of a locally thin sections or circumferential linear defects may be made on stream by installing a properly designed and applied enclosure. The design shall include the control of axial thrust loads. If the piping component being enclosed becomes insufficient to control the pressure thrust, the effect of enclosing the forces on the component shall also be considered. Again, see ASME PCC part 2, part 4 for additional details on this. During turnaround or other appropriate opportunities, the temporary leak sealing and leak dissipative devices, including temporary repairs on valves, shall be removed. Appropriate sections taken to restore the original integrity of the piping system. Procedures that include leak sealing fluids for process piping should be reviewed for the acceptance by the inspector or the engineer. The review should take into consideration the compatibility of the sealant with the leaking material. Pumping pressure on the clamp and any resulting crush forces and the risk of sealant affecting the downstream flow meters, pressure relieving devices or machinery, the risk of the subsequent leakage at the bolt threads causing the corrosion or stress corrosion cracking of bolts, and the number of times the seal area is repumped. Again, ASME PCC 2 part 3 for more information. We'll look at all this when we talk about ASME PCC code itself, but here some general details are given. Welding and hot tapping. All repair and alteration welding shall be done in accordance with the principle of ASME B313, that is the original construction code or the code from which the pipe has been built. The hot tapping requirements are done in accordance with API 2201. The inspector shall use the suggested hot tap checklist contained in API 2201 for hot tapping performed on a piping component. Hot tapping is creating a hole when the pipe is on stream. Okay, so if you want to have a different hole to apply a new nozzle or apply a new valve, in that case, when you are making a hole during the pipe is in service, this is known as hot tapping. Okay. Procedures and qualification. The repair organization shall use the welder and welding operators and welding procedures in accordance with ASME B313 or the code to which the pipe was built. See API 577 for the guidance on the welding procedure and qualification. We'll talk about this in great detail when we talk about API 577. In repair organization, the repair organization shall maintain the records of welding procedure and welder performance qualification. These records shall be available to the inspector before the start of welding process. Preheating and post-weld heat treatment. Again, these requirements are given in API 577. Preheating is heating the plate or the base metal before actual welding is done. This is generally done to minimize heat affected zone and to generally decrease the temperature gradient between the environmental condition and the base metal so that it will take a prolonged time for the weldment to cool down. The preheat temperatures used for making welding repairs shall be in accordance with the applicable code and qualified welding procedure. The exceptions for the temporary repair shall be approved by the piping engineer. Post-weld heat treatment of the piping system. Post-weld heat treatment, sometimes also known as stress relieving. In post-weld heat treatment is generally done so that you can restore the microstructure of the heat affected zone and to decrease the brittle failure of the weld, because sometimes wherever the welding is done, around that you have a high amount of heat affected zone where the grain structure has been changed to coarser grain structure. Sometimes it is considered to be martensite formation. Due to this higher size of the grain structure, the material may act more brittle, or the hardness might increase and it might act more brittle. To relieve the material or to bring the material back to its original condition, we would generally do post-weld heat treatment, that is heat treatment after welding. So PWHT or post-weld heat treatment of the piping system repairs or alteration should be made using the requirements of ASME B313 or the code in which the pipe was built. See 8.2.4 for alternative preheat and procedure for some post-weld heat treatments. Exceptions to temporary repair shall be approved by the piping engineer in accordance with ASME PCC2. The local PWHT may be substituted for 360-degree banding on the local repairs on all materials, provided the following precautions and requirements are applied. The application is reviewed and the procedure is developed by the piping engineer. Evaluating the suitability of the procedure, consideration shall be given to applicable factors such as base metal thickness, thermal gradient, material properties, changes resulting from post-weld heat treatment, need for full penetration welds, surface and volumetric examination after post-weld heat treatment. Additionally, the overall and local stains and distortion resulting from heating of the local restrained area on the piping wall shall be considered in developing and evaluating post-weld heat treatment procedures. Preheat of 150 degrees Celsius or higher are specified by the welding procedures and is maintained while welding. Required post-weld heat treatment temperature shall be maintained for a distance of not less than 2 times the base metal thickness measured from the weld. The PWST temperature shall be monitored by a suitable manner of thermocouples, minimum 2, based on the size and the shape of the material or area being heat treated. So how many thermocouples are needed? This requirement is given in ASME B313. So whenever we are looking at ASME B313, we'll talk about great detail about how heat treatment is done. Control heat also applied to any branch connection other than attachments within the PWST area. PWST is performed for the code compliance and not for environmental cracking assistance. Preheat or control deposition welding as alternative for post-weld heat treatment. So sometimes, in most cases, post-weld heat treatment is required, but there is an alternative to post-weld heat treatment. This is known as controlled deposition welding. So in controlled deposition welding, generally you have a single pass, and when you apply the additional passes on top of it, the additional passes will relieve the bottom passes and you would not need to have done post-weld heat treatment. So it's something like this. So let's imagine you have a welding like this. So you'll do first pass. When you do second pass, this second pass is going to relieve this bottom pass. When you do third pass, this third pass is going to relieve the second pass. Then fourth pass will relieve the third pass. Fifth pass will relieve the fourth pass. Sixth pass will relieve the fifth part, and then you can cut these. Okay, so in this case, post-weld heat treatment is not required. This is known as CDM, controlled deposition welding. Sorry. Okay, so it's something like this. Depends on you want to do post-weld heat treatment or not. If you do CD controlled deposition, then you would not need to do post-weld heat treatment. So, in some instances, full post-weld heat treatment may have potential adverse effects on the piping equipment. Nevertheless, the piping may have been originally post-weld heat treated or may require post-weld heat treating according to the original construction code. In cases In these cases, preheat and control deposition welding may be used in the lieu of post-weld heat treatment as described in 8.4.2, 8.2.4.2 and 8.2.4.3. However, prior to using an alternative method, a piping engineer shall assure that the alternative is suitable based on the metallurgical review. Preheating method Preheating method when performed in the lieu of PWHT is limited to following materials and welding processes. Material shall be limited to P1, Group 1, 2, 3 and to P3, Group 1 and 2. The welding shall be limited to shielded metal arc welding, gas metal arc welding, gas tungsten arc welding, and flux core arc welding. The welders and welding procedure shall be qualified in accordance with the applicable rules of the original construction code, except the PWHT of the test coupon used to qualify the procedure shall be omitted. The weld area shall be preheated and maintained at a minimum of 150 degrees Celsius during welding. The 150 degree Celsius temperature should be checked to assure that 4 inches of the material or 4 times of the material thickness, whichever is greater, on each side of the groove is maintained at minimum temperature during the welding. The maximum interpass temperature shall not exceed 315 degrees Celsius. When the weld does not penetrate the full thickness of the material, the minimum preheat and maximum interpass temperature need only be maintained at a distance of 4 inches or 4 times the depth of the repair weld, whichever is greater on either side. The use of preheat alternative requires the consultation with the piping engineer, who should consider the potential for environmental cracking and whether the welding procedure will provide an adequate toughness. Controlled deposition welding may be used in the lieu of PWHT in accordance with the following: notch toughness testing, such as established in ASME B313 Chapter 3 Section 323, is necessary when the impact tests are required by the original construction code or the code to which the applicable work has been planned. The material shall be limited to P number 1, P number 3 and P number 4 steels. The welding process generally is going to be SMAW, GMAW, GMAW, GTAW and flux core arc welding, FCAW. The WPS shall include the following items. So we already know this. First, we'll have a WPS. That WPS will be qualified by a PQR, and the welder's ability to make the sound welds will be done by a performance qualification of the welder. So WPS shall include the following requirements: the supplementary essential variables of ASME code section 9 paragraph QW250. We'll talk about this in great detail when we talk about section 9, but just introduction is given here. The maximum weld heat input for each layer shall not be exceeded that used in the procedure qualification test. The minimum preheat temperature for welding shall not be less than that used in the procedure qualification test. The maximum interpass temperature for welding shall not be greater than used in the procedure qualification test. The preheat temperature shall be checked at 4 inches or 4 times the material thickness on either side of the weld and maintained during the welding. If the weld does not penetrate the full thickness of the material, then it shall be checked at 4 inches or 4 times the depth of preparation, whichever is greater. For allowed welding process in item C, use only electrodes and filler metals that are classified by the filler metal specification and optional supplemental diffusible hydrogen designated of H8 or lower. Welding technique shall be controlled deposition, temper bead or half bead technique. The specific technique shall be used in the procedure qualification test. For weld made by SMAW, once filling it is completed, do not allow the weldment to cool below the minimum preheat temperature. As well, raise the weld temperature to 500 degrees Fahrenheit plus minus 50 degrees Fahrenheit for a minimum period of 2 hours. This assists outgassing diffusion of any weld metal hydrogen picked during the welding operation. This hydrogen breakout may be omitted if the when H4 filler material is specified. So in most cases, when the welding is done, if there is a loss of shielding gas, if your hydrogen, if your electrode has moisture entrapment inside it, you can have hydrogen entrapment inside the material, which can lead to delayed cracking or hydrogen-induced cracking later on. After the finished repair weld has cooled to the ambient temperature, the final temper bead reinforcement layer shall be removed, substantially flushed with the surface of the base metal. So this is the alternative to post-weld heat treatment. This is not included in the exam. Okay. Design: butt weld shall be full penetration groove welds. Piping component shall be replaced when the repair is likely to be inadequate. The design to temporary enclosures and repair shall be approved by the piping engineer. Fillet weld patches shall be designed by the piping engineer. Materials. The materials used in making the repairs and alteration shall be of known weldable quality, shall conform to the applicable code, and shall be compatible with the original material. Non-destructive examinations. So acceptance of the weld repair or alteration shall include non-destructive examination in accordance with the applicable code and owner user specification unless otherwise specified in API 570. The principles and practices of API 577 shall also be followed. When surface and volumetric examinations are required, they shall be in accordance with ASME BPVC Section 5 or equivalent. Pressure testing. Pressure testing is basically hydro test. We already know this. So after the welding is completed, the pressure test in accordance with 5.11 shall be performed if practical and deemed necessary by the inspector. The pressure tests are normally required after alteration and major repairs. See ASME PCC 2 Article 5.1 for more information on conducting pressure test. When pressure test is not necessary or practical, the non-destructive examination shall be utilized in the lieu of pressure test, substituting the appropriate non-destructive examination procedure for pressure test after alteration, rating, repair may be done only after consultation with the inspector and the piping engineer. For existing insulated lines that are being pressure tested after the repairs, re-rating or alteration, it is not necessary to strip the insulation on the existing welds. Pressure test with a longer hold time and observation of pressure gauges can be substituted for insulation stripping when risks associated with leak under the insulation are acceptable. When it is not practical to perform the pressure test on a final closure weld that joins a new or a replacement section of the piping system, all of the following requirements shall be satisfied. The new or replacement piping sections in the pressure tested, examined in accordance with the applicable code governing design of the piping system. If not practical, the weld shall be examined with appropriate non-destructive examination as specified by the authorized piping inspector. Okay. Any final closure butt weld shall be of 100% RT or angle beam ultrasonic flaw detection may be used provided the appropriate acceptance criteria have been established. PTMT shall be performed on root passes and completed butt welds and on completed welds for fillet welds. Owner user shall specify industry qualified angle beam examiners for closure welds that have not been pressure tested and for repair weld repairs identified by the piping engineer or authorized piping inspector. Re-rating. Re-rating is when you are decreasing or changing the rating of the piping system. So let's imagine if you have a class 1 pipe, now you are rating it to become a class 3 pipe. So you are decreasing the risk based on the change in operating condition or something. Okay. Re-rating piping system by changing the temperature rating or maximum allowable working pressure may be done only after the following requirements have been met. So let's imagine if you have a pipe that is already corroded, it is not able to sustain your original pressure, which is 200 psi. Now you can do one thing, you can decrease the maximum allowable working pressure. Now your pipe will have still some years of service. Okay, so this is what re-rating is. So calculations are performed by the engineer or the inspector. The piping system was built or by computation used using the appropriate methods in the latest edition of the applicable code or other industry standards approved by SDO. The current inspection records verify that the piping system is satisfactory for the proposed service conditions that are appropriate corrosion allowance is provided. Re-rated piping system shall be leak tested in accordance with the code to which the piping system was built or to the latest addition of the applicable code for new service conditions. The piping system is checked to affirm that the pressure relieving devices are present and are set at the appropriate pressures and have the appropriate capacity at that set pressure. The piping system re-rating is acceptable to the inspector or the piping engineer. Appropriate engineering records are updated. Okay, so this section was mainly how repair are going to get carried out and what are some conditions of the repair. Okay, in the next section we are going to see inspection of buried pipings. Okay, thank you. This was all for this video. We'll go in the for inspection of buried piping in the next video. Thank you.